Imagine a world where mobile gaming graphics rival those of high-end desktop systems. At SIGGRAPH 2025, ARM unveiled its groundbreaking Neural Supersampling, NSS, a pioneering AI-based upscaling technology tailored specifically for mobile GPUs. This marks the first application of what ARM refers to as ARM Neural Technology, a suite of features intended for future Mali GPUs equipped with integrated neural accelerators. The goal? To deliver desktop-class graphics on mobile devices while consuming significantly less power by rendering at a reduced resolution and employing AI to enhance the visual details. If this concept sounds familiar, it's because it closely resembles technologies like NVIDIA's DLSS, AMD's FSR4, and Intel's XeSS. The core idea is quite simple. Render images at a lower resolution. ARM's example illustrates rendering at 540p internally and outputting at 1080p. Then process the frame through a trained neural network to produce visuals that closely mimic native quality, all while using a fraction of the GPU's processing time. ARM is touting this as an industry first, but it's essential to note that this claim is specifically about mobile GPUs. AI-assisted temporal upscaling has been a staple in PC graphics for quite some time. If we want to stir the pot a bit, one could argue that NVIDIA and Nintendo have already implemented similar technology, as seen with the custom DLSS used in the Nintendo Switch. However, that might be a bit nitpicky. The standout feature of NSS is its optimization for mobile constraints. Unlike ARM's previous Accuracy Super Resolution, ASR, which launched earlier this year and utilized the main GPU cores, NSS is designed to operate primarily on a dedicated on-chip neural accelerator. This means it can deliver better performance without compromising the main GPU's workload. Now, let's delve into that impressive claim of 540p to 1080p in just 4 milliseconds. It's important to clarify that NSS is not yet running on actual hardware. The first devices are expected to be available in late 2026. The 4 milliseconds figure is derived from simulated data and performance predictions for the next generation Mali GPU's neural hardware. Currently, NSS is only functioning in emulation on desktop systems, and ARM has been transparent that real-world results will vary based on resolution, hardware configuration, and the specific workload. In a demonstration video showcasing a beautifully detailed Enchanted Castle scene, NSS clearly outperformed older shader-based upscalers, including ARM's own FSR2-based ASR, at the same low input resolution. Notably, common temporal artifacts such as ghosting or smearing, which often plague these techniques, were virtually absent in this demo. However, it's worth mentioning that the test was conducted under controlled conditions. There was no rapid motion, no intricate geometry, and no chaotic particle effects. While NSS does produce a softer and less detailed image compared to native resolution, on a 6-inch phone display, this difference is likely to be imperceptible to most users. One of the critical advantages of reducing the render resolution to just 25% of the native resolution is the significant reduction in pixel shading costs, which can drop by over 70%. In scenarios where the GPU is the limiting factor, investing approximately 4 milliseconds in an upscale pass can be a worthwhile trade-off. However, if the bottleneck lies elsewhere, the benefits may be less pronounced, and 4 milliseconds can still represent a substantial portion of the 16.7 milliseconds frame budget required for 60 frames per second. This is a balancing act that developers will need to consider, a challenge that is not unique to NSS but applies to DLSS and other similar technologies as well. Speaking of DLSS, NVIDIA's latest iteration, DLSS-4, has transitioned to a transformer-based model. In contrast, NSS employs a simpler CNN-based UNet architecture with recurrent feedback, making it more akin to DLSS-2 in its design. ARM has made the model fully open, providing access to its architecture, weights, and training tools on platforms like GitHub and Hugging Face, allowing developers to retrain it for their specific content. Whether this openness will extend beyond hobbyist experimentation remains to be seen, but the SDK does come with integration for Unreal Engine, Vulkan ML extensions, and emulation layers, enabling studios to begin development a year ahead of the hardware's release. According to ARM's presentation, NSS is merely the beginning, with additional neural technologies on the horizon. The company has specifically mentioned neural frame rate upscaling, NFRU, which likely refers to a frame generation technique, and neural supersampling with denoising, NSSD, which appears to be similar to NVIDIA's DLSS ray reconstruction and AMD's upcoming FSR Redstone. These advancements aim to facilitate real-time path tracing on mobile devices while using fewer rays per pixel. On paper, NSS represents a significant advancement for mobile graphics, both in terms of quality and efficiency, assuming that ARM's next-generation neural hardware can deliver the performance they are projecting. While the technology itself is not entirely new to the broader industry, if it performs as promised on devices expected in 2026, it could provide a substantial boost in visual fidelity, battery life, or potentially both for high-end mobile gaming.